in our short introduction, I didn't have a chance to tell you much about who I am except a kid from Texas who worked on a ranch. I've done a lot of stuff in computer science, a lot of stuff in biophysics, worked on the Human Genome Project, helped invent modern DNA sequencing at a company called Illumina, and now I do a lot of things for Singularity University that I helped co-found. This is what I actually do in my day-to-day work. I work on some fairly far out biotechnology projects under this label of Exponential Biosciences, which is sort of a consulting plus agency. I've got another company that is sort of an umbrella company over several other things where we're making toys and tools that are advanced biotech pieces of equipment, but for school children, because I think our future depends on getting them involved as quickly as possible. So we have a whole generation of scientists and doctors and engineers that will cure all of the things that are going to kill me otherwise. And then the last thing, and really where I spend most of my time, is there are a whole bunch of companies that friends, acquaintances, co-workers, students of mine have done and founded, and I help them hire people and raise money and solve problems, and I've done that a bunch of different ways. I haven't had an honest job for 12 years, but it works out. So that's my last commercial. You won't hear anything where I'm promoting anything, or if I bring up a company, I'll try to give you some full disclosure that I'm involved, because I never want people to not know. Let us start here. So this is what we said we would talk about, and I'll bring up the first question that I actually saw that came up on the app. Somebody said, and this is always the killer question to ask anybody in cellular agriculture, they said, well, what is the feedstock? What do you feed these cells so that they will actually go ahead and be able to grow? So the bad, stupid answer that had been true for 20 years and people doing these experiments was all of these cells are raised on fetal bovine serum, which means they would extract, from the womb of a cow, all the stuff that you grow baby cows. And obviously that is not a way that you come up with kill-free cellular agriculture, and it's not scalable, but that was sort of the early experiments. There were several people who made bad predictions based on the fact that they were using that's all they were ever going to use. The truth is now we're coming up with all these different ways to produce the complex of amino acids and growth hormones and proteins and all of the different nutrients that are needed, and do it from a fermentation standpoint. Actually program, usually yeast, to make the different components that are needed and grow this. And it's one of the big unsolved problems at scale. How do you do enough of this to do the equivalent of 20,000 herd of cattle? And so this is in some ways an unsolved problem, and it's something that people are working on and will present some of these solutions, and it's where some of the money is. Whenever we do investment in this area, this is a big deal. People who are still skeptical about this bring up the fact that if this whole cellular agriculture thing is such a thing, if we can make a steak for, $5 a pound, why can't we make a heart for $1 million a pound and implant that in somebody's chest? It's a different magnitude of a problem, but there's a point there, and there are some of these companies that we talk about that will fall out of the running where they won't be able to make structured meat, but they'll only be able to do cell slurries or some component of eggs or something that kind of looks like ground beef, and we'll talk about that. But I hope that addresses that one question. I'll bring that up again later whenever I show you somebody who is making the feedstock for cellular agriculture basically from sugar water. And it gives you an idea of how we think this does scale in the long term. There are a lot of technology drivers going on in here. We mentioned sensors, we mentioned a little bit about AI and automation, new materials, but reading and writing DNA is really the thing that has driven this. And the reading DNA, we've crashed the price, to give you an example, of reading a whole human genome from about $3 billion at the turn of the century to a little under $50 today. And that's the marginal cost of reading a whole human genome, but it also applies to reading plant genomes, animal genomes, being able to look repeatedly at different genomes and see what's going on, being able to use that for a lot of different applications. And then the other big technology driver is being able to write DNA. And that is going through equally a renaissance where it's getting amazing what we can do. This is my list of favorite acronyms. If I was going to give you one piece of homework, well, if I was going to give you one piece of homework, it's try an Impossible Burger and write down your impressions of it. And then try one again whenever the 2.0 comes out to a restaurant near you and write down your impressions of it and see if you feel differently about it, see what you personally think. The second piece of homework I would have for you is look at these acronyms. You don't need to know what they stand for. Don't worry about the small print. Look at the acronyms, and I want to share with you what they mean. And the next time you see one of these in the Wall Street Journal or the Pink Pages or the Statesman or something, there's some news story on it, read that story all the way through because it's going to affect you. This is going to affect everything about medicine, your future longevity, your family, but more and more agriculture, materials, manufacturing, these will all be big things. Here's what these acronyms are, and I'll just run through kind of at speed. CRISPR, it's a way to make molecular scissors, and they cut DNA where we tell them to cut. And it's what's bringing about, it's the main driver for the renaissance we're seeing in genetic engineering. CAR-T is a way to reformat the immune system of any animal with an immune system. We're doing it in humans, but we will end up doing it more and more in livestock animals and eliminating the need for a lot of the things that we do for medicine and vaccination now. CAR-T is a way where we can turn your immune system that's already a pretty good watchdog for disease or cancer into a bulldog and just go after things. SENT is a way to change one kind of a cell into another kind of a cell, and it's important for stem cells. And so this will be important both in cellular agriculture and in therapy. We'll want to be able to do a lot of that rewriting and repurposing of cells. RNAi is probably the thing that is heard about the least on here. It's gene silencing. It's a way to hit a mute button for a particular gene. And one of the applications that's really interesting in crops is you can grow a crop, a natural crop, the genome has not been affected, we've done nothing to it, and then walk into the field with a spray gun and spray the leaves of that crop and turn off one gene or turn down the expression of something and modulate it exactly. You're doing genetic engineering on it from the outside without changing its DNA, but you get the same effect. And in some ways, this is fantastic. In other ways, it's a little spooky. It could have some environmental consequences. The thing that kind of gets me is it's not being regulated at all because it's not changing the genome of the host animal or the host plant. Then the last thing, IVF, IVG, a little bit outside of our purview today, but in vitro fertilization, in vitro gametogenesis. And I talk about it and I call it the ability to, change sperm and eggs and nobody gets it, so I just change it to the end of sex, because that's kind of what's going to happen with this. And you see this in artificial insemination. It's always funny whenever we talk to cattlemen about AI, they're like, sure, artificial insemination. It's like, or artificial intelligence, and so we go back and forth. But literally in 20 years, you will see children born who then grow up and say to their parents, I can't believe you had me naturally. Do you see what I have to compete against, all these people who had all these different things twiddled with? I'm going to sue you, Mom and Dad. So we'll see that. I've got a question up on the screen. It says, in the New Zealand market, GMO has a dirty name. Further, a number of companies are built around traditionally manipulated products. How would you market gene silencing or gene editing to the NZ market? That's a pretty good one. And one of the things I want to be really clear, like I have no horse in the race. I have no skin in the game and what's going on. A lot of people look at me as this technologist who's telling them, all of your traditional ways will go away. Not at all. Or you must take these things and do them. I really just want you to be aware of them and be able to deal with them and make decisions head on and not be surprised by things. In the New Zealand market, you guys actually, because of the size of the market and the way it can be protected, might be better off staying natural New Zealand and kind of building that bioprotection fence that includes no gene manipulation. I think, though, finding ways to have little pockets of innovation will stand you in better stead going forward. For looking at this RNAi, marketing that, just calling it precision agriculture, saying here's this thing, the DNA is the natural DNA, but we have been able to influence how it grows to give you better taste, better flavor, better yield. One of the things that we'll talk about a little bit here is how important it's going to be radically transparent. And whenever we see both people who are doing things with their natural genomes and crops and animals, and whenever they are monitoring that and they find something that is cropped in that is not so natural, being able to both monitor it and be really upfront about that, being able to monitor things through and find disease, and instead of having to throw away the whole crop or the whole truckload, being able to figure out what are the things that you need to get rid of. But we're seeing the same thing with these companies that are trying to market these cellular agriculture products. They don't, try to sneak this in as an ingredient. They have, and we'll talk about a couple of these, proudly genetically engineered on the label. And they put it up front as a feature and then sell it as either being delicious, easy on the environment, something where it's cruelty-free, you're not hurting an animal, or it's a functional food that is taking care of something for one person. Here's another question. What is the non-animal growth serum derived from that you mentioned from growing cells outside the animal? We'll talk about that a little more, but basically where this is going, it'll come from sugar water. Just water and any kind of sugar, which you can get in abundance from so many agricultural inputs, be it cane sugar or even like recycling, repurposing peeled fruit is one of the ways that people have looked at doing this at massive scale for pennies on the dollar, being able to lower price below market price for beef or chicken. Let me go on. One of the ways that we see this very contemporarily, in fact, over the last 10 years, and this was something I was partly responsible for when I was at Illumina, we made products for looking at DNA, not just of humans and not just the whole DNA, but looking at sort of the most interesting pieces and being able to do livestock genotyping and precision breeding and looking at heredity became a big deal. We could sell these little genotyping chips and a little, to somebody who has tens of thousands of cattle in their herd. It became very price effective with a very good ROI to go ahead and be able to look and say, here are different traits that impact yield or health or viability, resilience, and we had a whole bunch of these and we would sell into different countries. We're now starting to see other traits come up, and we'll mention this at least later. How many people are familiar with A2 milk? Developed here, got a bad rap here, kind of came into its own in Australia, now in the US, and we're seeing anywhere from, that milk sells from 50% to 100% more than, regular milk. We still don't even know if the scientific case for it is absolutely true, but it looks good and people want it. The idea with A2 milk is there are certain cows that lack certain genetic traits, so they produce milk without some proteins that is thought to be easier to digest. And there are people who swear by this as a functional food. And so being able to do this kind of genotyping on your herd and on your breeding cattle and being able to go forward, those cattle are now worth so much more. Here's another bit, the whole idea that we can look at both our genetic makeup and how it varies from person to person and look at the different foods we eat, and can I pick a food, can I pick a diet that would be, more appropriate for me to lose weight or gain weight or take care of, do I really have a celiac disease? Am I really gluten sensitive? About 20 times as many people say they're gluten sensitive as really are, but we're finding other ways to figure out different food sensitivities and allergies. And this has gotten to be a big deal with companies who are trying to differentiate their products at the consumer product and good level. And here's another thing. This is just a little idea of where this technology goes forward. We're looking at being able to read DNA not just by taking a sample and sending it off to our lab, and here's a big $1 million machine and I run and I get you a result a week later or a day later. We want to actually have this, and we can now, in a form factor like this, where it's a portable genetic probe, and we can go ahead and effectively poke some organism, take some sample, and in 20 minutes for less than $20 is the goal. We want to be able to determine at least the species of any organism. And we want to do this. This is a Smithsonian project with Conservation X, which is loosely affiliated with Xenia's X Prize, where the idea is we could go ahead and do that at an import station, and we're able to say, here's a load of hardwood coming off of out of a shipping container, and let's go ahead and look at it. Yeah, that's the endangered stuff, that's prohibited. Send it back, or rather, we're gonna confiscate it and fine you $1 million, is how they roll in the US. Or, here's the ivory tusk, or even you say this is the fish that was caught in this area in this particular place that you're supposed to be able to do, but whenever we do our quick genetic analysis, we see no, or there's an unacceptable amount of dolphin, or whatever. Being able to do this on the genetic level and be able to do it very quickly against a background. There are also implications for being able to do disease management and herd management. Somebody comes up and they say, we found a single cow with mad cow. You can actually check all of the different cattle very quickly in a herd, even once they've been processed. And in fact, the genetic signature is something that we can check on the meat itself and track it all the way back to individual cattle and a feedlot. And so this becomes a thing also for agriculture, also for E. coli, being able to track diseases. So it's a little bit in the future. I tend to talk about things that are available now and pass the credit card test. This is something that's in the works, but I really expect this to be hitting industry in the next 5 years and available for personal use, kind of like a drone you can buy now for personal use, but you'll be able to buy a little handheld genetic meter. And don't get me started on the chaos that will reign from there. We'll be able to check people and see who's going to die of cancer first, or, is that really your kid or Uncle Bob's kid? So it's a whole thing. I got a little off track there. Here's a list of technologies that came from a study. I put together a list for both the World Bank and the International Development Bank. What are technologies affecting agriculture, and which ones are in particular going through the throes of this exponential change where we're hitting scaling laws, the price is dropping, the availability is increasing, and which ones of those in particular were a big deal. And just a couple of things. We talked about sensing and vision and how you can have even a cheap camera feed into an AI to do amazing things. We didn't talk about soil microbiomes. That's a little bit in the future, but all of your fertilizer, really what that's doing, it's working at that interface between the root and the soil and being able to program microbes that can do the same thing without artificial nitrogen fertilizers, or very little or just the right amount will be a piece. We talked about genetic engineering, in particular gene editing. We talked about cellular agriculture. We hinted at what we call farming or manufacture. Can you re-engineer algae or E. coli or anything with a yeast to go ahead and make things that you want it to make instead of what it's used to making? And that becomes really interesting, both as a way of manufacturing things, but a way of producing food and foodstuffs and very rare natural products. And at one point you start to look at being able to access some of the same things that a farm does, sunlight and water, but having a big pool of algae, maybe an open pool that is making some product that you want, and maybe being able to go in there and reprogram that algae to make more of one thing and another. It gets a little complex, and it's hard to believe me if I'm just waving my hands. I should do this as a whole separate presentation for you. But think about it. Sometimes people will call this fermented foods, but what they really mean is genetically engineering a microbe to make what you want it to make. Keep in mind too, it sounds so science fictional and far off. We've been doing it for 20,000 years. Yeast is how we make beer and bread. We just didn't know we were reprogramming the yeast. We were passing the best ones down through generations. Now we know exactly what to do it with pinpoint accuracy. We talked about the GMOs. Let's see, was there any other point? Did anybody have any particular questions? I was going to bring up this one piece. This is a big thing for yield. And I've got a question I'll come to in a second. This is a big thing for yield that we've got to increase over this next 30 years. And we're going to need to use all the tools at our disposal. And whenever you start to look at what this really adds up to, it's great. It's full employment act for any kind of agriculture. But what happens to the pricing and the availability? One of the pieces that people don't talk about a lot, but we're starting to see in the models that we've got, is even under worst case scenarios with climate change, with global warming, we will have enough calories to feed the world. We won't necessarily have the calories in the places we need it. So having to redistribute that is an energy cost and a real dollar cost. But being able to go ahead and grow those calories in the right places. The other thing we're starting to see is we won't necessarily have the nutrient-rich calories. You know, it's one thing to feed somebody rice. You're better off feeding them golden rice, or you're better off having a lot of other varied things in the diet. So we're coming up with some of that. I got a question. New Zealand is currently GMO-free. Does that have value to a premium global consumer, or are we missing opportunities? You guys tell me. In some ways, I think the size of the production in the market, that you guys can build that fence and say, yeah, you know what you're getting exactly. I actually, though, think that the marketing around this changes. People have started to look, now that labeling is mandatory, and it hasn't made a big difference in sales in the US about GMOs. Whenever somebody says, you know, here are my GMO-free almonds, and you're like, yeah, nobody has ever genetically engineered almonds. That's kind of like, here's my fat-free drinking water. And you start to feel like you're being lied with or messed with a little bit. There's a little bit of a pushback. There's a pushback on organic. It's like, do I really need to pay twice as much for this? Whenever you look at fruits and the dirty dozen, are they really dirty? Is it horrible? Should I avoid these fruits, or can I just wash them in the sink? Or can I go ahead and buy organic? And why is it so expensive? I think by totally closing off, that it's a mistake, because you will not have a chance to make new industries around this. But I think you could go ahead and have like the highest biosurveillance and say, whenever we certify something as GMO-free, it really is GMO-free, not just because the country is GMO-free, but because we know what we're putting out and things are not contaminated, and being able to do that. And that's a data problem. That's not really a seed problem. This is all my opinion, and I would love to engage with you guys one-on-one the rest of the day. Moving on, we talked about the Simplot potato. Here's some actual data on this, and I will include this in the slides that I distribute if you want. And it's not hard to go ahead and get some of this information off the web, but it gives you an idea. And to me, this is one of the perfect examples of both consumer traits, where it's an easy to peel, doesn't go brown, and also traits for food preparation. If you're running a commercial kitchen or some sort of food preparation service, you want to have something that's easy to peel, that at some point you can give to a robot to peel. Here's my other favorite example of this. And this is an example where a lot of the things that people complain about on GMOs have to do with, it's a big business, and you've got, and you know, I don't have a problem with the big players in the field, the Monsantos and the Cargills. I have a problem with the way they've handled some stuff in the past, but I think that they do a really nice job, and they tend to be very ethical. But we're getting away from having to have the resources of a big business to do this kind of research and do this kind of production. My favorite example being Okanagan Specialty Fruits, a family-owned orchard in Canada, where one of the people who had inherited this had gone to school and said, man, my agronomy degree is showing me this genetic engineering thing is a big deal. What could we do? And they said, we could actually make an apple that you can slice up and put on a conference table, put out, and it doesn't turn brown all day. It's this pretty nice apple. Now, you can do the same thing. You go to McDonald's and you get your Happy Meal with the kids, you get French fries or an apple, and the apple comes and it stays white. It's because they've drenched it with calcium, and at some point that's not good for you. This is the natural way to do that. They said we could breed this apple, traditional breeding methods, that's about a 30-year project. Or we could do it in about 2 years and go in and turn down phenol production in apples so that that thing that makes them brown, we just have a lot less of it. It's gonna have the same nutritional profile, no new genes in there, nothing that would affect the taste. It's an appearance thing. And so they did this, got it done in about 2 years, went through a marketing campaign that was more intensive than the technology, where they said, this is what we're doing, proudly GMO'd, proudly gene edited. This is the exact sequence that we put in. Let us teach you about it. Here are resources for school kids to understand what's going on. And then during this time, they get approval to start selling the trees in Canada and the US. And then they get bought for $41 million fairly quickly, which was much more than they had been worth as just an orchard. So very interesting, I think, business case, how that worked. Here's the other thing, genetic engineering is no longer something that is concentrated in the US. We're seeing this all over the world, and I've got several things listed, and some of these are some of the US projects that are fairly well known, but Argentina, we mentioned earlier with Bioceres, Canada with Okanagan Specialty Fruits. Colombia is actually coming online and trying to reinvent their agriculture away from poppies, let's say, and do some more interesting things, including beans, and they say, easy to digest, so it doesn't make you fart, is what it really is. And Spain, now the most interesting thing, China is financing more projects in crop and livestock than the whole rest of the world put together, governmentally and commercially. The other thing that's interesting about China is China, whenever you look at how much does the population approve, in the US it's about 50-50 or 60-30, kind of depending on how questions are phrased, but most people eat gene-edited things and don't go out of their way to worry about it, or actual GMO food. In Europe, it is switched the other way around. In China, it is 95 to 98% of the population is against any kind of manipulation of genetics of food. And it's because the population in China, which for most things will follow the Communist Party, does not trust their government as far as food. They've seen melamine in the baby formula powder. They've seen everything adulterated. They've seen kitchen grease reused and sold as new oil. And all these things have really built up where they're like, we'll give our lives for anything except the food thing. But the government keeps putting huge pressure on, because if you look at the demographics and you look at what's available for water and arable land in China, they've got to do something. My whole point with this is, over the next, I think 7 to 15 years, China will make a decision about will they be importing genetically modified food they already do it for some of their feedstock for livestock, will they do it for their populace? And whenever that happens, we're not gonna care what France says, we're not gonna care what the US says, everybody will fall one way or the other, because that will be the biggest import market. And as they progressively allow more things, which is how I think it's gonna go, we'll see more and more countries fall in line. So, and that has some bearing on the whole, does New Zealand stay natural New Zealand too? Here's a whole thing on what's going on in Brazil, and part of it's in Portuguese, pardon me for that, but they are doing a lot of things where they're basically have developed their own industry. The interesting part is acreage of GMOs planted. The US has been doing this since the first Reagan administration. Brazil, you can see, is just exponentially increasing what they are doing, and it's getting to be bigger and bigger. And they may double their arable land again with changing how the Cerrado works, hopefully without burning rainforests. And here's a little summary of some of the animal pieces going on. And I don't want to just exhaust you guys by being pedantic about it, but I think the history of gene-edited animals is kind of told with pigs. And we talked about BGI's micropigs. The most interesting thing going on, if you actually look, and we'll see in a second, what's going on with protein production in China. A lot of that is happening because they've been genetically engineering, either through guided breeding or actually direct genetic engineering, to go from litters of 7, 8, and 9 to litters of like 22. Pork is their main meat mainstay, and it has just gone through the roof. The aptly named PIC, Pig Improvement Corporation, does a lot of this work. There are pigs where they've had myostatin edited out, and they are super muscular with very little fat, and they are actually being actively raised and sold in China. And it's kind of funny, every once in a while you can go into a fancy hotel in Beijing, and on the buffet, you've got this really lean bacon, and I'm like, myostatin pig. I'm pretty sure that's what it is. They're the low-fat pigs, and then finally, and this is where it gets a little weird, and this is a worldwide project too, in the US and China and Europe, people are changing the immune profiles of pigs so that pigs can become organ donors for humans. And that sounds really odd, but about 40% of deaths occur because there aren't organs available to transplant, heart, lungs, skin, etc. And pigs are very close. And so this idea that you could go ahead, eat all the bacon you want, have a heart attack, then get a pig heart transplanted, and then go ahead and eat some more bacon because there's the pig left over. So it's a thing, but kind of whenever you look at this, there's always something interesting going on, and the pig is a fabulous both experimental animal and, partner in agriculture. We looked at cellular agriculture. We looked at these companies. I did want to just bring up, whenever I talk about cellular agriculture and I say, and new food, there's 3 things going on here. So 1, the companies that are actually producing consumer goods today are not, strictly speaking, cellular agriculture. They are protein replacement and plant protein. And I'm talking about Impossible Foods, Perfect Day, a couple of the other ones that are on there. And that is something that is scaled very quickly. Maybe there's a little bit of genetic engineering going on in how they source the heme in the Impossible Foods. So they use a bunch of plant proteins, and then they use a genetically engineered version of plant heme that is analogous to blood that you find in mammals, and that's what gives the burger its sizzle. One of the things, and this speaks to, I had promised we would say, what happens to marketing in this case. The profile, the nutritional profile of an Impossible Burger is not anything like meat. Is it better for you? Is it worse for you? Are you more or less likely to gain weight? Is it high fat? Is it high carb? It depends on what version it is and what they're doing. And so you kind of know what you're getting with steak. You don't know necessarily with the Impossible Burger. It's important to look at those nutritional profiles. The other thing that's going on is just straight cellular agriculture in here, the idea that we can grow meat outside the body. And then I've got another question here. Alternative protein companies have focused their marketing efforts quite heavily on demonizing the farm industry. How do we tackle that and change consumer perception? That's a fantastic question. I think going ahead and that radical transparency and saying, you can go ahead and hit all the heartland pieces of this is tradition, this is how we do it, you know what you're getting. And also, hey, we have been working on feeding the world for this long. This is what we're doing to lower environmental impact, and even little changes make a huge change both in consumer perception and what people are willing to pay. We've shown over and over again in these basically marketing studies. So I think that's very interesting. Moving on from here, this is, and like I say, you guys can get a copy of this. This is called The New Protein Landscape. It's updated by a woman named Olivia Cabane, and I have a link to it in the slides, and you can actually read it in the slides. But this is my little bullet list of investment theses. Whenever we look at the companies that are in here, because we think less than half of them will be around in about 5 years, which ones will be around are the ones who are first going to work on ground meat. That we think that's the first product out. Second, have technologies that are able to do vasculature. There's about 3, 4, 5 ways to make veins in this lab-grown meat, or they would have us call it clean meat. And that's sort of the trick. That's the thing you want to be able to do so you can grow more and more of this. What is the feedstock breakthrough? We'll talk about that in just a second, about that sugar water piece. And this is the marketing that I think survives, where they aren't demonizing. They're just like, do you want to not kill an animal? We can do that. And they're not going to, go and show PETA pictures of farms or ranches. And they will say, we have natural foods with near zero environmental impact, and finding ways to measure up and challenge that. Before I get off of this, do you guys want to hear the horrible thing that nobody in the clean meat industry would want to ever have you market? So whenever you bite into one of these lab-grown burgers, basically it's a ground-up tumor, which you're never going to see on a Subway ad, I'm just saying. But whenever we immortalize tissue and we grow it out of the body, we're turning on all the things that we turn on in cancer. Now, you can't catch cancer from it. You can't do that. And man, I've worked at a meat packing plant. I know how many things get thrown on, taken off the hook. They're not, doing a checkup on the animal at that stage. But if you go ahead and word it that way, it's kind of like, I don't know if I want to try that. Let's have some other people try it first. Tailored functional foods, I think, will be another thing where you don't have to have mass-wide appeal, although you will have people who are like all-natural, non-processed foods, and people who are all-natural, low-impact on the environment foods, whether it's processed or not, and you'll have maybe this little middle where that meets too. Tailored functional foods where you need something out, you've got a food allergy. Everybody probably knows somebody that you go out to a restaurant with who has to have it gluten-free and low salt, and I'm allergic to this particular thing. Being able to, 1, analyze that with a handheld analyzer, and 2, have foods that are actually labeled and quality controlled for that. And again, and I will say it again, radical transparency in revealing what your processes are in your labeling, in your marketing, will win the day on any side of this piece. Here is something I wanted to show off. One of my students lives in Tokyo. His name's Yuki Hanyu, and he has been a believer in this whole cellular agriculture. His thing is, someday we're going to colonize Mars, and whenever we do it, it's going to be really hard to load up a spaceship with a herd of cattle or turkeys or anything else. He goes, but we're going to want to still be able to eat the things that we eat on Earth. He goes, we will grow meat in tanks, and that's where he started. And he's been working on this for almost 10 years. And he looked at what had happened with the GMO industry and how it had gotten demonized and people still fear it. They don't understand what's going on. He said, we can't let that happen with this whole idea of cellular agriculture. Let's make sure people understand what's involved. Let's make this thing that looks like a microwave oven, let's make a desktop myoformer where people can grow meat at home. Let's give this away to school children, and they can do little science projects, and they can grow things and try things. And we can talk about how will we make feedstock for the future? How could we use sugar water to make all the nutrients that we want? What would be the pluses and minuses? He actually publishes a comic book, and because this is in Japan, it's a manga, and so it's got all these anime characters, and they're all flying to Mars, and they're all growing crazy meat things in their meat vats. But he's doing this so that there's a generation of kids in Tokyo who's familiar with this. They're like, of course this is going to happen. And let me show you what I grew at home. And I made this little flavoring, and we can go ahead and spread this meat paste on the sandwich. And it's amazing. And he's just started in the last 2 years to get recognition for doing this. And after the fact, he's then started his own cellular agriculture company. It's called the Shojin Meat Project. You can find it on the web. It's all in Japanese, so good luck. But we're actually trying to raise some money to translate it all into English because I think it's this neat educational tool. And the big deal is he's not pushing this like you must do this or it's bad for the environment not to do it. He does a whole thing, make a choice. What do you think? Here are the facts. You should be familiar with it if you're going to be a citizen of the future. Let me do this. Let me run through this graph unless we have more questions, and you guys let me know or I'll watch the screens. But this is one of the analytical pieces that I want to show to give you an idea where I think this is going. One of the places to cut to the end of the story is I think we will see cellular agriculture as a meat product replacement, and we will see it in the ground beef area absolutely first, and this is why. So this is world protein production over like the last 50 years, and the big story going on here is it's increasing, but not as fast as we want it to increase. Asia is the big increase, and you heard me say before, it's because you're having pigs with different yields and bigger litters, and most of that's genetic engineering, just straight up. We're actually seeing a big increase in South America. And if you look from the beginning to the end, Africa is doing fantastic. It's just that it's starting small. Here's the big problem. It's not that we won't have enough meat to feed the world. It's we don't have enough meat for all the new rich people who are entering the middle class from emerging economies. This is a complicated graph. This goes on a little bit, but what's going on is here's meat consumption per capita on the vertical. Here's per capita GDP. And then every dot there is a country. Big dots are big countries. And if you look at this over time, all these countries are moving from poor countries that don't have much meat to big countries that eat a lot of meat, including China and including India, which is the third largest producer of meat in the world. You just don't think about that because it's not just a Hindu population. So this is the one that really shows the tail. Not per capita consumption, but national consumption. China beat the US a long time ago, and then is moved up to be more than 2x meat consumption, most of it in pork. So people will say, what do we do to take care of this meat gap? Couldn't we go ahead and do something with plants, with soybeans? Soybean production is going through the roof because of genetic engineering, most of it in Brazil, most of it in the US, and almost all of that is going to China as animal feed. People say, well, maybe it doesn't need to be plants. Surely we have other things that are not land animals. What about the whole fishing thing? Almost no one knows this. That red line, tons of fish that we pull out of the oceans. And you see it goes up, and in the 90s it starts doing this, and it kind of evens out. We've reached the ocean's capacity through any kind of natural fishing. In different places, we will overfish and crash populations. Those regulations are not just a bunch of environmentalists whining. It's a real thing. We're getting better at managing it and managing fleets and getting everybody to agree that's their livelihood. The blue line is aquaculture, fish farming, both onshore and offshore. And it is going up exponentially, thank goodness. It's going to keep going up, we hope. But it's past. We now pull more tons of fish out of fish farms than we do out of the ocean. And then here is the last one, and this is the one that tells the tale. How much land do we use per gram for different kinds of proteins? Beef is the one at the top. So land use combined with environmental impact, combined with what people are more and more starting to worry about, global warming, this makes that a big deal. We either have to find ways to minimize both the environmental impact and land use and have traditional beef and cattle, or you're going to be having a lot of lab-grown meat burgers. So that was the last part I wanted to show you guys. We're out of time, but I would love to take any questions that you've got. I'm looking forward. I've got a couple of things that I've got to do with other meetings here today, but I really just want to circulate and talk to people and have you tell me where I'm wrong, have you tell me what I don't know. Anybody have anything we should end with? Any more questions? Yes, sir.
Why don't we just create like the perfect food product based on nutritional quality and is that where it's going to end up?
The question is, why don't we just create a perfect food product based on what we need and want and what we nutritionally need? Nutrition is like one of the worst understood things that we do, but we're getting better and better at it. And we're actually looking, and we know that actually that's an individual product for different people and different groups of people. But kind of one of the interesting, more weird things that's coming out of the cellular agriculture, there's a project I work with called Revive and Restore. Has anybody heard of this? We think in the next 3 years, we're gonna bring back at least the first extinct species. It'll be the passenger pigeon, where none of them exist alive. We're gonna go ahead and take tissue samples out of museums. We're gonna be able to basically clone the birds and start breeding them and reintroduce them to the wild. One of the other things that is gonna happen, I think, fairly quickly in that project is bringing back the woolly mammoth. Frozen woolly mammoths have been found, and we got the tissue. But before we get a full-grown woolly mammoth, there are a couple of companies that are now working with this tissue and are saying that they're not gonna bring back woolly mammoths and slaughter them and make steaks, but they're gonna bring back the cells and do the cell culture. And I was like, good luck selling that. They're like, no, you don't understand. This has got to be delicious because this is the first animal that we ate into extinction as the human race. I was like, okay. And if you want a perfect paleo diet, woolly mammoth, man. So, and I don't mean to be flip. I think that there are people who are working on exactly that. We've seen some stuff that I think is really left field, like Soylent, where we had a guy who was a food scientist try to reconstitute all the things that you're supposed to have in a perfect diet from chemicals, and then he made it into a shake. And it was like this weird little corner thing, and all of a sudden he was selling millions of units of this on the internet. There's some people who swear by this, but to me that's a little bit too much like having a food pill. It's not the same thing. I think we will see more perfected and functionalized foods, but I don't know that we actually know what those should be yet. Yes, ma'am.
So Raymond, what are the business structures most capable of executing against this agenda? In other words, tell us a bit about the disruption to existing business models.
That'll be my last question. And to repeat it, what are the business structures that are most capable of executing against this agenda? And how does this sort of play into disruption? The ones who are being the most successful right now are very small, agile startups, small teams, not marketing things, not selling things so much as solving technical problems right now, and then allying with large food producers or marketers and saying, how are we going to be able to work together? Once we get the technical details and the scale solved, how can we use your resources to do the next bit? And it's sort of a classic disruption model. Take all the best things that a small team can do, find a giant in the field who will take a chance on it and can go ahead and lend their expertise and power. And I think that is who we're seeing who so far has been successful and will be successful. I don't think there's a good way to work against that except by becoming that. We've met the enemy and they are us. And so finding ways to do that with traditional industry, that's a tough one. I'm gonna go ahead and let you guys go and go to lunch. I really appreciate you listening to me blather. Get my information, slides at raymondmccauley.net, and I look forward to having more conversations. Thank you.
Thank you very much.